Hello, everyone. Welcome to the latest meeting of our AI engineering book club. And today we are going to talk about evaluate AI system. And today we are a little bit different from the previous sessions because we have a volunteer speaker, Mir Ali. So Mir is currently a graduate student at University of Texas Arlington, and he does a lot of the AI stuff. And he also prepares a very good quality slide and presentation for today's session. May I please take it away?
Yep. Thank you, Lee. Uh, uh, just sharing my screen. Just 1 minute.
Yep.
Yeah. Is my screen visible?
Yes.
Yeah. So yes. Before starting the talk, so anyway, it has been emphasized by everyone, all the industry experts in AI engineering and in AI, where evaluating your systems is the most important very important part of building an AI systems. So for any solutions. So I feel like this is a very important chapter in the book, which presents us a whole new world with multiple sections, which will help us debug and understand and take approaches of go moving towards the solutions and our criteria. So before we start, let's take a recap of previous chapter. First thing is like we understood LLM metrics, cross entropy, entropy, and we understood how evaluation occurs. And after that, how we can use AI as a judge. So working on that, we have three main sections in this chapter. One is evaluation criteria. Second thing is model selections, and third one is designing our evaluation pipeline. Now, let's start with the first section. Before we even try to build any model, we always need to understand how are we going to evaluate. So that is based on different criterias we go ahead with respect to our solutions. So that is why this chapter emphasized specifically on evaluation criteria. Now, they start with an analogy where they ask which is worse, where if an application, uh, which is worse, whether an application which has never been deployed or an application that is deployed but no one knows whether it's working. And ideally, many people have already experienced people have said that the one, if an application is deployed and no one knows whether it's working, is more worse because we don't even know what is affecting and how much and why we are using it. So because of that, sorry. So we need to understand how our application will be evaluated. So this term is called evaluation-driven development. So let's take an example where if we are using recommender systems, we can evaluate it based on engagements, whether it has increased, decreased, or purchase through rates. And for fraud detection, it'll be how much money we have saved from preventing frauds. With respect to coding AI assistance, it'll be how much functional correctness of our code has been generated. And different multiple ways of evaluation is if you have intent classification. These all are close-ended. That means you just need like metrics, true and false, binary. So those classification methods can be used there as well. We can use our evaluation criteria. And this is the most biggest bottleneck in adopting AI in any stream and any domain. Now, in evaluation criteria, there are multiple sections and multiple phases where we need to understand the capability of the model or AI solution which we are going to build. So it has been generalized into four capabilities. One is domain specific, generation capability, instruction following capability, and cost and latency. So first, let's go ahead with domain-specific capability. Now, what is specific capability? Uh, First, if let's take it with an example where if we are building a coding agent, whether the model can write code, that is a domain-specific capability. Another thing is if you are writing an application where, as a translator, Latin to English, the model must be able to understand Latin and English. Or it makes no sense. And how can we know if a model has that domain-specific capability? Uh, Simplest and easiest way will be we'll have to rely on benchmarks, which can be private or public. In public, we can go through multiple benchmarks and understand that is there in that will be discussed further in the chapter. And examples are code generation, debugging, grade school math, science and knowledge. These are all other. And what are the use cases? With respect to coding related, consider if we have functional correctness. That means if we want to write a function and if it has been implemented, is that all? No. The issue is considering, let's take an example of if very common use cases, writing a query, SQL query. So there we cannot expect just the solution to be right, isn't it? Because there might be a chance that the code is right, but it can take forever to run, or the efficiency is very bad. So these things also takes time. And this is one thing we need to make sure, and that is efficiency and cost. And their efficiency can be exactly evaluated by runtime and memory usage. These are multiple ways of evaluating our efficiency and cost for the model. And one of the benchmark which is already available is Bird SQL, which also takes care of account of accuracy and efficiency, which will be compared with the ground SQL queries already, which is available in the benchmark. But what about readability now? Because there are chances where it is highly efficient and cost effective, but there is a chance that it won't be readable. For that, we can use AI as a judges. That we'll see later on. And already we have discussed where we can use AI to understand if it's readable, it's not readable, and convert it to metrics. Now, what up? Since until now we have talked about coding part to get a hang of it, but what about non-coding? How can we do it? Now, for that, usually non-coding tasks are open-ended tasks, so it will be quite difficult to even evaluate them. So what we can go ahead with is how do we convert the open-ended task to closed-ended task so that we can understand if a domain-specific capability is there in our model or not. So for this first easiest thing, why we need closed-ended tasks, main reason is that we can reproduce them. Even if you are utilizing or iterating over it, it is very easy to reproduce. And where can we see? And simplest thing how to understand this is we'll have to go through benchmarks. Now, where do we find all this close-ended tasks? That is in Luther's LM evaluation harness, we have multiple choice questions, which consist of 75% of multiple choice questions. It's similar in UC Berkeley and AI2 reasoning as well. And in paper AGI evals, authors explain how open-ended questions were excluded to avoid inconsistency in assessments. Now, next, what are the metrics we can use with MCQs? The simplest metrics will be accuracy, but if we are using classification, that is yes or no, there we can use multiple different statistical metrics, that is F1 score, precision, and recall to evaluate our systems. Now, are there any drawbacks? What can happen with MCQs is the model's performance can vary just with small changes. That is, uh, um, with space or a special extra character in between question and answers or options. Now, this is quite common. The reason we all have already discussed, that's tokenization. The way the tokens form can change as well. Now, what can be the solution for that? Because that's a problem. Now, this can be reduced using prompt engineering best practices, and that will be further discussed in next chapter. Now, This we have understood domain-specific capability until now. Now, how about what is a generation capability? Now, what do we mean by generation capability? That means if someone is talking in English, how do we know that that person is talking quite good English? That is like we'll see fluency, that is grammatically are they correct, coherence, whether what they are speaking is well structured, and faithfulness, that means whatever they are speaking, is it in line with the context, what they have started with, and relevance, are they talking with respect to what the talks are going ahead with. Now, but lot of fluency and coherence issues were in the past, that is 2010s NLP models. But currently with LLMs, we there's it's very difficult to even differentiate between human generated text and AI generated text. So human fluency and coherence has become less important of talk. So and but still these can be evaluated using AI as in judge. But in generation capability, what happens is like the issue comes up, which is quite well known in LLMs, that is hallucination. What is hallucination is where a model starts generating text which are quite far away from the facts or which are not aligning with the facts. Fortunately, these are very much important when we are having a creative tasks, but it is not well received for task dependent facts. Uh, and next is safety. There can be a chance where the model can be very toxic, or it can speak about biases. A very common biases is where nurses are uh, uh, models more prawns to nurses with respect to female gender, and for males, it will go with other aspects of professions. Now, are there any other measurements of developer measurements which we might care about or developers care about? Yes. With the example is AI-powered writing assistants. We'll have to take care of controversiality, and few other things is friendliness, positivity, creativity, conciseness. Because now consider if we are having in simple scenarios, we are consultant bot, doctor consultant bot. It is very important that the responses are very friendly and gives positive response. Now, but right now we'll be focusing mainly on factual consistency and safety, because these are one of the most important aspects when we are trying to build a solution on foundational models. Now, in this, there are two types of factual consistency which we'll have to look into. First thing is it is known as local factual consistency, and second one is global factual consistency. In local factual consistency, it is nothing but we are evaluating with respect to a context, similar to rack systems. And we'll have to check if the facts generated and the fact or context which are being provided are in given context. These can be important for summarization, customer support of chatbots, and business analysis. And another thing is global factual consistency. Now, these are the things where it's a well-known fact. We don't need a context, where it is an open knowledge. Like example, sky is blue, ocean is blue, uh, soil is brown. So these kind of known facts are things which are in factual consistency, and we expect the models to know or solution to be right. These can be important for general chatbots, fact checking, and market research. Now, it's easy to verify explicit facts, but the hardest part will be what facts are, because it can be very easy to fall for absence of evidence fallacy. What does evidence fallacy mean? Now, if we take an example where if we could determine if there's no link between X and Y, now there can be a chance there'll be a failure to find evidence of finding the link. Due to that, it will say it can derive that there's no link between X and Y. Now, main note what it's been provided in the chapter is where whenever we are trying to design, whenever we are designing metrics for hallucination, we'll have to analyze the model's outputs to understand which query types are more likely to generate hallucinations. Now, one example they have provided is where for Math Olympiad, if the queries were for more of a Math Olympiad questions, but it started generating hallucinations because mostly it'll be normal American Olympiad questions and those things will be there, and it will be very difficult. And model has not seen that, so that's why it'll start hallucinating in those kind of scenarios. So we need to understand what kind of data sets the more data has been trained, or which all kind of queries it will start generating hallucinations. Now, still, again, when we are continuing factual consistency, we'll have to assume that we already have a context to evaluate outputs. And so if we have that, then AI judges can judge them. But in case we need human evaluation, we can come back. But mostly, if we have context and we have generated outputs, AI judges are more than enough. Or mostly, they are preferred. One of the benchmarks is truthful QA, measuring how models mimic humans' falsehood. Shows they fine-tuned model GPT were able to predict truthful statements, which were considered by us humans with 90 to 96% accuracy. This shows that how good their fine-tuned model was able to match our predictions. Now, sophisticated AI is judge techniques. One thing is self-verification, where if model is generate, these are the few things which we can use AI as a judge to yeah, to mitigate or to catch factual consistencies. Where in first thing is self-verification, where if a model generates multiple outputs, we can check, we can verify every generated output with each other and see if they are disagreeing or not. If they are disagreeing, that means our original output is likely to hallucinate. Second thing, in this paper of safe augmented factual evaluator created by Google DeepMind, they talk about knowledge augmented verification, where it consists of four steps, where we decompose the responses into individual statements and we revise each statement to make it self-contained. That means if there's we bring the original subjects into the sentence. So this is a sample from the paper where the prompt is what is Eiffel Tower, and the response is the Eiffel Tower is a tower in Paris. That's right. It opened in 20th century, and the Nile River is in Egypt. So what Safe Augmented Factually Safe does is it will split this into four sentences, and it will revise the self-contained. That is, it is Eiffel Tower. Others are already self-contained, so we don't need to evaluate it, and it will check with Google Search API. Now, once it has, we'll check fact checking has been performed. If there's, and it will give a score, which is supported, not supported, and irrelevant. This is another way of checking for factual consistency. Now, in this, we can verify whether a statement is consistent with a given context. It can be can also be framed as textual consistency. Sorry, textual entailment, my bad. This textual entailment is a task of determining the relationship between two statements. So what can happen is if uh, it can only give three hypotheses. One is entailment, both are inferred from the same premise. Contradiction, if the hypothesis contradicts the premise, that is, two statements are contradicting each other. Neutral, where it neither entails nor contradicts. An example is if we consider Mary likes all fruits. In entailment, Mary likes apples, so she likes fruits. It is matching. Now, in contradicting, Mary hates oranges. Now, this is contradicting our Mary likes fruits. But if we say give a statement where Mary likes chickens, now it can neither contradict nor entail. So this becomes a neutral. Now, We can say, doesn't this make an classification task? And yes, that is how, sorry. Now that is what it is. We are trying to convert it into a classification, close-ended solutions. Now, Hugging Face had developed a Deberta V3 base MNLI fever and the model, which is just 184 million parameter. Right now, we are in billions, so it feels very small. Which is trained on 764 annotated pairs of predict to predict entailments. So with this, we can now considering instead of just using foundation models, now we can use these small models to how to check our factual consistency if we are able to convert our requirements. Now, are there any benchmarks? Yes, there's a Truthful QA, which has 817 questions, which is spanned across 38 categories, and these include various categories: health, law, finance, and politics. Now, factual consistency is very crucial evaluation criteria for RAGs, that is retrieval augmented generation systems. Uh, Now, next is safety. Now, in safety, other than factional, model can be harmful in many other ways. That is, as I said, different safety op solutions have been categorized as harms where to now, what do we mean by safety? It is inappropriate languages, harmful recommendation and tutorials, hate speech, including racist, sexist, and other discriminatory behaviors, violence, including threats and graphic details and stereotypes, bias towards political and religious ideologies. These are all, uh, if these kind of outputs are being generated and by our AI system, then it's unsafe. So for this, there have been multiple solutions now which have been categorized with respect to different harms. And we have OpenAI's content moderation endpoints, Meta's Llama Guard paper. These are all are by our organizations where they are able to bring safety solutions and with their own way of categorizing the harms. Now, what in safety, it's possible to use general purpose AI judges to detect safety scenarios, but models developed to detect toxicity in human generated text can be used for AI generated text. And these tend to be much smaller, faster, and cheaper, just like how we check with factual consistency of human Hugging Face model. Now, there are things where we there are already models which have been trained, but depending on the way it has on the data it has been trained, there are high chances that they can be biased. So this is from a paper. The diagram is from a paper where they try to plot it. They have plotted on where whether the model is more biased towards left wing, right wing, or is it or authoritarian or a libertarian. It's quite an interesting graph where we can understand looking at this that uh, it's not all about just training, but the data what we are given to the model and what it has inferred from the training data sets. Now, there are benchmarks where to detect toxicity prompts, and few are for safety. One is real toxicity prompts, and another is bold by Dharma et al. Uh, so this is until safety. Now we have gone through domain-specific capability, generation capability, but next we need our model to follow what we ask it to do. That is instruction following capability. Now, what does it mean? It's just how good is this model at following the instructions you give it, and why do we need it? This will be a core requirement for foundational models, being able to follow instructions. One of the example is Instruct GPT, which was before ChatGPT. It was trained on instruction dataset, where it could. That's why it was named Instruct GPT. And generally, more powerful models are better for following instructions. And instruction following capability is essential for application that requires structured outputs, where if we need a model to give us XMLs or JSON outputs, uh, instruction following is quite mandatory there. And not just that, like if we usually there are chances where we tell prompt to reduce it to 2 sentences or reduce the length, or we give specific length outputs. That is where it must be capable enough to follow the uh, instructions. Now, how well a model performs depends on the quality of its instructions, that is, one-way prompts, which makes it hard to evaluate AI models because if model performs poorly, it can either be because model is bad or instruction is bad. So, once we select a model and we keep running our prompts and debugging them, if after some while, if it's not happening, that means we will have to go ahead and change the model and see if it works with other models. Now, there are multiple instruction following criterias and different benchmarks have different notations of what instruction following capability is. Now, if eval has instruction following evaluations, InfoBench, it takes much broader view of what instruction following is. And from if eval, these are the combination, a table, this is a table in if eval where we try to infer what each instruction group is and what instructions are found and with the descriptions. Now, these are good with benchmarks, but we should be able to curate our own benchmark to evaluate our model's capability to follow our instructions using our own criteria. These are very helpful in looking at it and understanding which model to choose ahead with, but at the end, it's our solution, what we have to bring it out. So it's very important that we must be able to create our own benchmarks if possible. Now, this is one of the most used instruction following capability. This is role playing, where if we ask, and it is one of the most common types of real world instructions, where purposes are entertainment or prompt engineering technique to improve the quality of models output. There are, and we have benchmarks of rule LLM and character eval. And if AI is an application supposed to assume a certain role, we have to make sure that it adheres and we are able to evaluate such that model stays in that character. There's not much because this will come again. We can talk about role playing. It will come in the prompt engineering part. Now, next is cost and latency. Uh, what what is the point of having the best model if you are not able to run it, or it's too expensive to even run or use it? So we need to be very clear that what are our objectives and what are the things which what we can compromise or we can't compromise. So there are few metrics, latency metrics, that is time to first token, time per token, time between tokens, time per query. So time to first tokens is usually when you run a query on the model. There are some pre-fill stages, that is, you'll have a whole prompt which has to run through and then it will start generating text because it's an autoregressive models nowadays for LLMs. So until the first token has been generated, there is time to first token and time per token, as it states for each token, how much time it takes, and time between tokens. So like how much time it takes from one token to another token. And per query, these are the simplest common metrics. Now, latency can not only depends on underlying model, but it can also depend on the each prompt and sampling variables. That means if your prompts are too long or very long, so that will also take some latency and other sampling variables. Now, if we are hosting our own model, the cost outside engineering, compute cost, engineering cost is compute. Other than our outside engineering, the compute is the main cost. But if you're using open API or model APIs, the main cost usually are cost per token, that is input and output tokens, which are usually, and it won't change with respect to scale. It'll usually stay constant. Now, we have gone through evaluation criteria, evaluation metrics, and all the criteria is how we have to evaluate. After this, once we have decided, okay, how we are going to evaluate our model, what we are going to do, next main part is how do we select models? Now, we don't care about the best model available outside in the market or in open source or APIs because we only care the model which is best for our application. For this, there is a workflow because every day, in every few days, we have SOTA, state of the art getting released or new metrics being released. So how are we going to go ahead with that workflow? So there are a very generic workflow which has been provided in the book, where first they ask us to decide what are the hard attributes are often the results of decision. That means what are the model providers, can we take? That is licenses, training data, model size, or do we have our own policies? Whether your organization or your project has your own policies, privacy and control. And there are some soft attributes which can be improved on. That is accuracy, toxicity, and factual consistency. And in model evaluation workflow, we have consists of 4 steps. First thing is filter out models whose hard attributes don't work for you. There are some cases where uh, you don't want your data to go through API, and that's why you're like, no, everything is out. We are just using open source model, and we'll have to use publicly available information. That is nothing but benchmarks, LLM leaderboards, and after that, since we have already created our evaluation pipeline in the previous section, we have our evaluation pipeline. We'll have to run experiments with our own evaluation pipeline, and we'll have to continually monitor our model in the production so that we can detect failure and collect feedback to improve our application. Main thing, I think this is not much of a decision right now with model build versus buy right now because most of the companies can't build a foundational model from scratch. So it's all about whether we are going to use commercial model APIs or we are going to host our own open source model. And if we go into nitty-gritty, open source model is something where the model weights and the training data is publicly available. And open weight models are the ones where we don't have the data which they have been pre-trained on. And nowadays, almost most of the models are open weight models. And for nuances, after this section, we'll be referring open weight models as open source models. Now, there are a few things we need to know about in open source world as well. There are some very well-known licenses which we need to know about. That is Apache 2, GNU, General Public License. But now there comes already, it was very difficult to understand and get nuance with all the licenses with respect to an enterprise world and in corporation world. But now open source models have their own different unique licenses. Like example is Llama 2 has its own Llama 2 community license agreement. Then Hugging Face, Big Coder had Big Code, Open Rail, MV1 licenses. Each license has its own policies where they allow and disallow you with few tasks and things. Now, while evaluating licenses, we need to bring up few questions. That is, does the license allow commercial use? If it allows commercial use, are there any restrictions? Does license allow using the model's output to train or improve upon other models? If for few people, if you don't know, like there was few claims going on whether DeepSeek model has been distilled on our OpenAI's model and things. So these are the things which licenses allow and disallow. Now, still in this, there are few services which host the models in open source models and receive user queries and runs the model to generate responses, queries, and return these responses. These are called inference service models. And Cohere and Mistral are open source. They have open source models and they provide API and they have their own APIs for larger models. As that's quite common where the best models are saved for the APIs where they can earn, and little uh, lesser models are usually open source. Even OpenAI is a commercial model where they have open source models such as GPT-2 and Clip. And model APIs can be available through model providers, cloud service providers, or third-party providers. An example is we can go ahead with GPT 3.4, where we could get it from API of OpenAI, and we could even come through cloud, that is Azure GPT-4. Uh, and we can even have third-party API providers that is for open source other models which can be used from them. Now, they each have different features, constraints, and pricing. Based on our requirements and things, we can select them. But commercial models are only accessible via API licensed by model developers. To decide hosting the model, or we are using model APIs that can use, or should we use model API? We have 7 accesses have been derived commonly. First thing is data privacy. Is it okay for us to go ahead with sending our data to model API? Now, in the book, they have already given reference to a Samsung's user case where the data had been breached, where they had sent private documents in the chat GPT by Samsung employees, and it was able to be found. Now, data lineage and copyright. Now, there is very less transparency about what data model has been trained on. So there are a lot of IP laws and regulations around AI are still revolving around. So there are multiple cases where now if you think about this, I the first thought that okay, if it's like this, then open source model it is. But there are chances where open source model, so that is open weight model, can be trained on an uh, IP data, that is intellectual property right data. Now that'll make me liable because depending on the license. So that's why there are many companies they opt for commercial model because they sign a contract where with model providers. In this way, they can protect themselves. So these are multiple things, multiple ways we can decide which model to use, and using this we are reduced. Now next will be performance. Now performance, it's just like based on benchmarks where we'll see which models do we need, but usually open source model are closing into proprietary models, but they are not equal yet, or they have not outmatched them yet. The main reason of what they have stated in the book is where there is not much incentive for model providers to get be able to beat them. And one major problem is getting feedback because once it's an open weight model, anyone can use it for themselves. So the feedback loop is not coming up. Where with respect to proprietary models, we have APIs and report. It's a feedback loop which they can occur. Now, one more thing is functionality. The functionality can be like scalability, function calling, structured outputs, output guardrails. Output guardrails is where, with respect to safety, what we had discussed, where we need to see whether it's not toxic or if it's very positive, the way we want. Now, these are very challenging and time consuming. And there might be a chance where some APIs might not even provide log probabilities, which can be used for classification tasks. Log probabilities are nothing but in normal autoregressive models where you get the token, with token you know what is the probability that this was a token, like the softmax thing. A lot of providers they provide, but they provide or might not provide as well. Most of them don't provide this. And these can be used for classification tasks, knowing whether the output is very confident or not. Based on this, we can even evaluate and interpret the models. Now, this, if not that, we can only use fine tuning. And we can fine tune our the model only and only if commercial model provided. If you're going ahead with the commercial model. Now, one more big thing which the organization or a team has to think about is whether should we go with API cost versus engineering cost. Having an open source model is all about engineering cost as well. Now, at a certain scale, if a company is bleeding with lot of resources using APIs, they might think about their hosting their own models. But hosting models has its own issues, where has its own requirement, that is not trivial time, talent and engineering, optimizing the model, scale and maintaining inference services, and API. And if you're going with API, we need SLA, service level agreements. And with this, we will need standard APIs, because if you have standard APIs, then we can switch the models whenever we want. And usually most of the APIs mimic OpenAI's API. Now, control access and transparency. In the 2024 study, the two key reasons why enterprise care about open source model is control and customizability. And with the reason for this is like if they want to tweak based the way they need things. Now, there was a use case. What is the question? Oh, so the question is, for instance, if a company uses a commercial model on their own data to fine tune, there would be no benchmark they could follow. What do you think they could follow as a benchmark? It is based on just the data available, or would they benchmark? How would they benchmark, do you think? Now, first thing is like commercial. If there's any commercial model, just it's according to my knowledge, where if they are able to fine tune. Now, As we talked at first, right? Benchmark is actually the way the benchmarks has come up is a way for you to remove the models which are not usable for your use case. Now, if you want to benchmark, I think after this, benchmarking is usually to uh, evaluate multiple models, different kind of models for that performance. I'm talking with respect to public benchmark. Now, if you want to really now, and is it based on just the data available, or how would you benchmark? This is based on our use case. How are we going to evaluate our models based on the solution you are trying to build? Hope I've answered, or is there any question with regard to this?
Yeah, I think that's any question
Okay.
as well.
Okay. Thank you.
You are muted, Mia.
My bad. Okay. And next, API guardrails. One of the main issues with API guardrails, why people might go with open source models, is if you're using normal APIs, commercial APIs, what will happen is they'll have their own API guardrails where for their own safety, that is with respect to licenses and policies. Now, if few companies want to generate real faces, it'll be very difficult for them to use commercial APIs to generate real faces because of the guardrails implemented by the commercial APIs. So because of this, they tend to go towards open source models. And one more major problem will be risk of losing access to commercial model. There might be a chance that it might be banned in your country, or they can update their model without letting you know, making our prompts very difficult. Again, we'll have to reprompt all our prompt engineering. So these are because of all these use cases, and there are multiple various reasons where there can be a chance that they can stop. So this gives them more control and they can customize it. And another thing is on-device deployment. If the plan is to build it on Raspberry Pi, like an example, I'm just giving Raspberry Pi or mobiles, or that is on device, third-party APIs are out of the picture, and we'll have to go ahead with the custom open source model. Now, this is with respect to model selection, and this is a table which is already available in the book with respect to our aspects, which models have its pros and cons. So all cons are in italic and pros are in bold. Since it's shortage of time, I'll have to skip this. But this is what we have discussed about. And how do we navigate the public benchmark? Now, we need to know that tools that help you evaluate models on multiple benchmarks called evaluation harness. And the few examples are Luther's AI's LM evaluation harness supports 400 benchmarks, and OpenAI runs almost 500 existing benchmarks, and they even allow you to even submit new benchmarks. And how do we select benchmarks and aggregation? Now, this is because there are so many benchmarks and they are just upcoming. Every time we are having new paper coming up with new benchmarks. So benchmark results help you identify promising models for your use case. It's not like to select the best model, just a promising model, and you can disregard other models. Aggregating benchmarks results to rank models gives you a leaderboard. Now, here, what benchmarks to include in your leaderboard? How to aggregate these benchmarks results to rank a model according to our use case. We always have to think with respect to our use case, whichever is helpful or not. And in public leaderboards, if you go ahead, it is helpful, but it is not comprehensive enough because of compute constraints. Running these benchmarks takes a lot of compute with respect to the model. And many leaderboards, they have very few benchmarks. They leave out a few benchmarks, and different leaderboards often even end up with different benchmarks. And they try to balance coverage and number of benchmarks. And main thing is benchmark correlation. Benchmark correlation is nothing but if you have a lot of multiple the benchmarks, we can run a correlation between them and see how much they are matching with each other. And we need to know what capabilities does one leaderboard try to capture. because they'll have some five benchmarks. So if I go with an example with OpenAI's benchmark, this OpenLLM leaderboard, they have IFEval, BBH, Math, GPQA. I'm not sure what it is, but MUSR, MMLU, and CO2 cost for each benchmarks and things. So based on this, we can see, okay, what is this for? This is for me. Do these benchmarks fall under my category, or are they matching what I need according to my requirement? And now, custom leaderboard with benchmarks, we can create our own custom leaderboard based on the list of benchmarks. You can match them and with your own evaluation pipeline. Then evaluate how reliable a benchmark is, since many benchmark might not be measuring what you expect them. The goal of this process is to select small subset of models to do rigorous experiments using our own benchmark and metrics. Now, this is one thing. Then again, there's data contamination issue where with public benchmarks, where model was already trained on public benchmarks. Because at the end, model is trained on the script data which is available in the open web. So using that, so there might be a chance that model can be trained on that. Then how can this happen? Mostly unintentional. It can be accidentally scraped, and this can also happen intentionally, because if they remove the old public benchmark, that really good benchmark, they might with if they train on that, there might be a very high chance that it will perform very good. It can improve huge performance. Now, how can we handle data contamination? What they can do is, like, there are two approaches, that is ngram and perplexity. In ngram, it's accurate but very time complex. Ngram is nothing but consecutive uh, and split tokens. If I say tokens, where it is available through model output and it is overlapping with the data set. And one more thing is perplexity, how difficult. That is nothing but log props, which the model will provide for each token. If the model's probability is very less, that means it's not confident enough. And that means it has not seen the data. If it's very high, that means it might have seen the data. That's why it's very confident. When this paper was trying to analyze GPT-3's contamination of carbon benchmarks, they found that 13 benchmarks were at least 40% in the training data. So in training data, there are already those benchmarks. And to combat, leaderboards host like Hugging Face plot, standard deviation. And there are multiple places where public benchmarks help you filter out bad models, but they won't help you find the best model for your application. This is the main goal of going through benchmarks and getting the very small subset which we can do rigorous experiments on. Finally, once this is done, the design evaluation pipeline, I think we can finish this fast because your talk. There are three steps. One is we have to evaluate all components in a system. So taking an example, like we are extracting a person's current employer from their resume PDF. We have extract all text and extract all current employer from extracted text. So these are two different components. Now there are two types of evaluation we can do. One is turn-based. That is, at first step, we have completed, so we know what we are entering and what we expect out, and we can evaluate on each component. And task-based, that is, the whole task is extracting a person's current employer from the whole PDF. So at the whole task, how good is it completed? Now, challenge of task-based evaluation is it can be very hard to determine boundaries between tasks. Now, next is now creating an evaluation guideline, which we had discussed, then defining evaluation criteria, where it's very difficult for us to know what is good output for an application, because correct response is not always. Like example is, like, they had given a scenario where if LinkedIn, if you're asking if I'm a correct fit for a job role, or what if it gives you back as you're a terrible fit? That's not how we want. That's right, but that's not good response. So we'll have to think in three criteria, that is relevance, factual consistency, and safety. This is what the good correct response, the safety, which guardrailing, which we have talked about. And it's very good to create scoring rubrics with an example. And where in this we can have scoring rubrics of 0 and 1, then 1 to 5, 0 and 1. And contradictory, entailment, and neutral, what we have talked about. Some people even use three values. And main thing is, whatever metrics we do, it must align with our business metrics. If it doesn't align, then it just beats the purpose of building this AI solution, what we are trying to build. So whatever application we are doing, it must be in context with business problems, and we must be able to understand the impact of each evaluation metric. Because if a evaluation metric is less, or like 30%, we must know that okay, business context with respect to business, it's going to hit 50%. If it hits 50, then business metrics can each 80%. This is how we must be able to evaluate and relate with each other, how much impact they are going to do. And before developing any AI evaluation metrics, it's very crucial that we need to understand business metrics, what we are trying to target. Then the last step is selecting, defining evaluation methods and data, uh, where we are selecting evaluation methods, different criteria, whether we have log props available, automated metrics to be, and whether we must see whether these evaluation methods can be considered for production as well, because that will help us in bringing users feedback, and it will be helpful in improving the application. And if there's any way we can annotate evaluation data in an automated or using a human feed, using a human in the loop, that's very good. And they talk about how it's better to slice the data. What they are talking about slice data is, once we take the data, we slice it into fine-grained understanding. That means each subset, we take samples from, like we have 100 samples, 100 examples, we take 10 samples from same examples. And each sample will have its own different understanding of the system when we use it. So here we slice data to gain fine-grained understanding of the system. Here slicing means separating our data into subsets and looking at systems performance for each subset separately. Then using this, we can avoid potential biases. We are able to debug, find areas for application improvement, and avoid falling for Simpson's paradox. This is nothing but where phenomenon where model A performs better than model B on aggregated data, but it's very worse on model B on every subset of data. That means like if we have k subsets, but on aggregated, if we evaluate it, model A is better. But if we go ahead with checking with each subset, that means it's really bad on all those things. That means we need to understand where we have to improve and why it's failing. And we need to have multiple evaluation sets, that is slicing, and number of samples in evaluation data set should be large enough. It's a common thing for evaluation set also needs a compute and resource and time. So number of samples in evaluation set should be large enough for evaluation results to be reliable, but small enough to not be prohibitively expensive to run, because at the end that also takes an expense and time. And we have to evaluate our evaluation pipeline, where it can, if we keep evaluating evaluation model, it can help in improving pipeline's reliability and finding ways to make pipeline more efficient. And some questions we need to keep asking is your evaluation pipeline giving us the right signals? Is it reliable? How much correlated are the metrics, that is with business metrics, and how much cost and latency does our evaluation pipeline add to our application? And last thing is we have to keep iterating over this, since we have created a pipeline, and we need to make sure that our all experimentation, we are tracking and logging all variables that could change in evaluation process. That can be prompts, your hyperparameters, your models, all those things. And the next week we are going to work on prompt engineering. And yeah, it was the presentation. Any questions?
Yeah, thanks so much, Mia. It's very detailed and also very clear. Really enjoy your presentation.
Thank you.
Aradia and Nirud, do you have any questions?
I don't think we have any questions right now. I think you answered it. But yep, thank you for the presentation. And
Yeah, please go through the chapter. It's way better and way nice and more depth than what I could even explain.
I
It's all
think
just a tip of iceberg.
yep. And one more criteria I found. I think it would be interesting discussing is the evaluation metrics as well, because
Mhm.
we discussed all over evaluation criteria
Mm-hmm.
to end, but the metrics would also be, uh,
Mm-hmm.
you know, did you
Yeah.
did you
So,
get my
mhm.
did you understand what I suggested?
So you're suggesting, since we have talked about evaluation criteria and things, you're asking like if we could explain more about metrics.
Yep, yep,
Like there are some metrics, if we could state few metrics which makes it easier to understand
yep,
and
yep.
relate to. Is that what you're trying to say?
Yeah, yep, 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 yep.
So what happens here is, since this has been very generic for open-ended for anyone who can follow it, now this evaluation becomes very specific to the use case what we have right now.
Yep, correct.
Like, so based on that and your data and your organization, so you know, or we know what we need for how to evaluate with respect to business. Because at the end, we spoke, right, where the evaluation metrics are good and criteria are good, but if it does not align with the business outcome, then it doesn't make sense.
Yep, yep, yep. 100%.
So that is where like they're bringing terms will become very specific to one problem set. So that's why like we try to reduce things, but actually go through the book. There are few examples. Bringing those examples would have made it even more lengthier, which was not good.
Oh yeah.
Yeah, so that was main reason. But there are considering recommendation now, there are few cases where uh, PDF extracting, their evaluation metrics. How will we go ahead? We will go ahead with accuracy, how many we have got, or we can say how and percentage we have got out. Those and all things will be there. So how are we going to evaluate? That'll be a thing really specific to us and the business use case, from what I understand.
Yeah, I recently also was reading a paper which was released by University of Berkeley, I think, and
Mm-hmm.
uh, yeah, University of California, Berkeley. They had a recommendation data set which is specifically generated using ChatGPT. They have like Amazon C4, which was
Mm-hmm.
Amazon reviews, which was generated using ChatGPT. And I think as we go into depth, it becomes domain specific. It becomes the use case specific of anything. Whatever I ask, if my question would be like the previous question, whatever I asked, like that would be also be like domain specific and the use case specific. How much ever it
Yes, yes, yes,
yeah,
yes.
I understand.
Because evaluation, it's very difficult on an open-ended thing. Just chatbot won't work out. Uh, we
Yep,
can't evaluate it. So there again, you'll have to again close your boundaries or bring some boundaries so that you are able to know you're going in the right direction. So that those are the
yep,
things.
Mhm.
yep. Uh, that is 100% true because while working on a business use case, like recently I was working on in a company which I don't want to mention, and so the data we wanted to fine tune whatever the data we had to create benchmarks because we had several models which we were training, but to benchmark it would we would just compare with the models which we have trained. Other than that, because whichever the model which would be
Mhm.
performing better there, that would be the only model which we would be considering. There would be no specific benchmark as you told, and that's true 100%.
So that is what they were trying to make people understand in this chapter is even we before we go ahead with training the model, because AI engineering is mostly we are using foundational models right now, right?
Yep,
So they are like, why are we even using this? The solution, what are we trying to solve? What are we trying to target? That is business metrics or business criteria. So based on that, we will start evaluating, go a step back, go a step back, go a step back. And slowly, slowly you build your evaluation criteria. Then next, we will know how are we going to know whether this is a good or bad, what we are coming out.
yep,
After that, we will know, okay, what models to select. Now, you guys might have already selected few models and fine-tuned or trained on them. Now, that's the thing, right? Like, if you don't know how to evaluate, even training will look pointless, because at the end we will only see numbers, losses of models and things. So that is that is like a quicksand. We don't know how to get out most of the time. So
And
yeah.
I think most research, like whatever the advancement is happening in AI, like for an example, if new technology or new model comes up every week now and then, when I think I follow papers with code more often to just see what are the GitHub repository which has come up. Uh, Always, it is a like a repetitive process of benchmarking one above the other, one above the other. But the research should be shifted towards data centric, because depends on the data also, right? Because we have for an example, if you consider like largest population countries, they would have humongous amount of data, but that data is not being properly associated or meant to be used. That is one thing I think most I think my ideology is like most focus should be on data also, rather than just focusing on the model also, right?
Mm. Nice. So, uh,
And thank you for the presentation.
no, yeah, thank you for attending.
Yep.
Any other questions?
I don't think I have any other questions.
Sure. Yeah, I mean, yeah, I think we are all in the Discord channel, so feel free to
Yeah.
continue this very important topic discussion in there.